Okay, so throughout this video I will be recording solutions to the 2019 VCAA Exam 1 for Further Mathematics. Exam 1 for Further Mathematics is a 90-minute exam with 15 minutes of reading time, and you may use a CAS calculator and a bound reference throughout. In 2019, you would have completed the core module of the exam with 24 questions, 16 of those on data analysis and 8 of those on recursion and financial modelling. And you would have completed 2 modules with 8 questions on each of the 2 modules. However, in 2020, you will only be completing the core plus 1 module. And so the timing for this exam is slightly different than what it will be in 2020. So in 2019, you would have spent 36 minutes on the data analysis, 18 minutes on the financial maths and recursion, and 18 minutes on each of your chosen modules. In 2020, there'll be more questions in each area, and you will do 45 minutes on data analysis and 22.5 minutes on financial and your chosen module. For the purposes of these videos, I'm going to record the solutions to the core component of the course, so data analysis and recursion and financial modelling, and I'm going to also record solutions to the Matrices module, which is by far the most commonly completed module. The instructions on the cover page should be relatively familiar by this point. There's nothing overly surprising there. Exam 1 is a complete multiple choice exam. And so let's get started on those multiple choice. So data analysis first up. This should take you 36 minutes to complete the 16 data analysis multiple choice questions. So the histogram below is relevant to questions 1 to 3, and it shows the distribution of the population size of 48 countries in 2018. So it's a histogram. It certainly looks like the scale's not very appropriate, and I suspect at some point they're going to suggest we do a log scale here, but let's have a look. The number of these countries with a population size between 5 million and 20 million people is. Okay, so this is simply about being able to read off the plot. So population size in millions is on the horizontal axis, so therefore this is 5 million here and this is 20 million here. So simply counting up, we can see there's 11 in that category, there's 4 in that category, and there's 2 in that category. So 11 plus 4 is 15, plus another 2 is 17. So 17 countries have a population between 5 million and 20 million. Question 2. The shape of this histogram is best described as... Okay, so it's clear there's quite strong skew here. It is positively skewed, given that it's been pushed from the positive end. And I would say there is definitely looks like there might be an outlier. So in terms of the shape, positively skewed with outliers would be the answer that I would give there. Question 3. The histogram below shows the population size for these 48 countries plotted on a log 10 scale, as predicted earlier. So we've now got a log scale describing the population. Based on this histogram, the number of countries with a population size that is less than 100,000 people is. Okay, so the log scales essentially means that each of these numbers on the horizontal axis represents 10 to the power of that number. Okay, so this 1 here is 10 to the power of 1, so it's 10. This 2 here is 10 squared, so that represents 100. Okay, so 100,000 is 10 to the power of 5, so that's going to be there. So 5 on the log scale would be 100,000, and we want the number of countries with a population size less than 100,000. Okay, so that would be 100,000 there. So it looks like there is 7 countries in that group and 1 country in that group. So there would be 8 countries with a population size less than 100,000. Okay, questions 4 and 5 are based on this STEM plot, and the STEM plot shows the distribution of mathematics test scores for a class of 23 students. We have the key telling us how to interpret the score. For this class, the range of test scores is, okay, so we know that range is equal to maximum minus minimum, and so therefore in this case the maximum value is 89 and the minimum value is 40. So the range is 89 minus 40, which is 49, and so D is the correct answer to question 4. Okay, question 5. So the same STEM plot. For this class, the interquartile range of the test scores is. Okay, so we need to work out the quartiles. So I like to think about the median first and then divide each half in half again. So if we have 23 pieces of data, the median is the 23rd, I'm not going to say that it equals something, is the 23 plus 1 over 2, so it's 24 and 2, so it's the 12th piece of data. Okay, so what you're going to have here is you're going to have 12 bits of data, sorry, no, you're going to have 11 bits of data, then you're going to have the median, and then you're going to have 11 bits of data, and that's how you get 23 bits of data. Okay, we then want to split each of those 11s in half. So the middle of the 11th piece of data, add 1 to 11 and divide by 2 gives us the 6th piece of data. So actually, Q1 is going to be the 6th piece of data, median is going to be the 12th piece of data, and Q3 is going to be the 18th piece of data. So that means we've got 5 bits of data in between there. Between the 6th and the 12th, there is 7, 8, 9, 10, 11. That is another 5 bits of data, 5 bits of data, and 5 bits of data. So you've got 5 plus 5 plus 5 plus 5 plus the 3 pieces of data that actually represent the quartiles and the median. So that's how we're going to need to divide things up. So the 6th piece of data is Q1. Okay, so so 1, 2, 3, 4, 5. So the 6th piece of data is 57. 7, 8, 9, 10, 11. The 12th piece of data is 68. 13, 14, 15, 16, 17. The 18th piece of data is 75. Okay, and then yes, we can confirm we'd have 5 bits of data after that. So it's 5 bits of data, then Q1, 5 bits of data, then the median, 5 bits of data, then Q3, then 5 bits of data. So therefore, interquartile range is Q3 minus Q1, and so that is 75 minus 57. And so 75 minus 57, if you're not sure, or it's late in the afternoon and you're not confident in your number work, your interquartile range is going to be 18. Okay, question 6. The time taken to travel between 2 regional cities is approximately normally distributed with a mean of 70 minutes and a standard deviation of 2 minutes. The percentage of travel times that are between 66 and 72 minutes is closest to. Okay, so let's think about what we've got here. So we've got a normally distributed variable. The mean time is 70 minutes and the standard deviation is 2 minutes. So 72, 74, 76, 1, 2, 3 standard deviations below the mean, 68, 66 and 64. So we want the percentage of travel times that are between 66 and 72 minutes. Okay, so 66 is 2 standard deviations below the mean, and 72 is 1 standard deviation above the mean. Okay, so we know that within 1 standard deviation of the mean is 68%, so that means there must be 34% between the mean and 1 standard deviation above the mean. We also know that 95% of the distribution is within 2 standard deviations of the mean, so that must be half of 95% there, so that is 47.5%. Okay, and so therefore we're going to need 47.5% plus 34%, so 47.5 plus 34 gives us 81.5% between 66 and 72. Okay, question 7. The volume of a cup of soup served by a machine is normally distributed with a mean of 240 mils and a standard deviation of 5 mils. A fast food store used this machine to serve 160 cups of soup. The number of these cups of soup that are expected to contain less than 230 mils of soup. Okay, so again, we want to think about, well, what percentage is less than 230 mils, and then work out that percentage of the 160 cups. Okay, so what was the median? 240. So 3 standard deviations above and 3 standard deviations below. So if the standard deviation is 5, this would be 235 and this would be 230. Okay, so we want less than 230. So what we're seeing is 230 is 2 standard deviations below the mean, which means in between here is 95%, which leaves us with 5%. So 2.5% will be up there, and it'll be 2.5% down there. Okay, so we want 2.5% of the 160 cups is going to be the number of cups that were less than 230 mils. So that is 0.025 times 160, 0.025 times 160 is 4 cups of soup. It had less than 230 mils in them. Okay, question 8. Percy conducted a survey of people in his workplace. He constructed a two-way frequency table involving 2 variables. One of the variables was attitude towards shorter working days, and people either nominated as being for or against. The other variable could have been. Okay, so a two-way frequency table is when we have 2 categorical variables. So one of the variables, attitude towards shorter working days, for or against, this is a categorical variable. So therefore, we need to look at which of these options is another categorical variable. So age in years, that's a numerical variable. Sex, male or female, that's a categorical variable. Let's just check the other 3. So height to the nearest centimetre is numerical, income to the nearest $1,000 is numerical, and time is also numerical. So B is the only other categorical variable there, so it must be the other variable in the two-way frequency table. Okay, questions 9 and 10. A least squares line is used to model the relationship between the monthly average temperature and latitude recorded at 7 different weather stations. The equation of the least squares line is found to be, and we've got the equation there. When the numbers in this equation are correctly rounded to 3 significant figures, the equation will be. Okay, so this is not a question about regression or data analysis. This is a question about rounding. And this is a reaction to the fact that every year they comment on the fact that students struggle to round correctly to significant figures. So 3 significant figures. So the first significant figure is the first non-zero digit. Okay, so in the case of the 42.9842, 4 is the first significant figure, 2 is the second significant figure, 9 is the third significant figure. We then look only to the very next digit. Everything after this becomes irrelevant. We look to the 4th significant figure, and that tells us whether we should round up or not. So the 8 tells us we should round up, which means this 9 will round up to 0, and therefore the 2 will round up to a 3. So this will be 43.0. correct to 3 significant figures. So therefore we're straight away down to just C or E. And then again, the first significant figure is the first non-zero digit, so that is the 8. The second significant figure is 7. The third significant figure is 7. We look to the 4th significant figure. We ignore anything that comes after that. The 4th significant figure tells me that I don't need to round up, and so to 3 significant figures, my answer will be 0.877, and so that should be option E. Question 10. The coefficient of determination was calculated to be 0.893743. The value of the correlation coefficient, rounded to 3 decimal places, is. Okay, so the first thing we need to look at here is, okay, that we've got negative slope, which means we have negative correlation. Okay, so what we know, coefficient of determination, we know that r squared is equal to 0.893743. Now when we solve that equation, when we take a square root, we get positive or negative square root of 0.893743. But we know that we want the negative, and so therefore we know that we need the negative square root. You can verify that if you solve the equation rather than just take the square root yourself, r squared is being equal to 0.893743. We solve that for r. We get positive or negative, and that's where we then need to be able to look at, either we'll be given a scatter plot, we can see whether it's a positive or negative correlation. In this case we've got the least squares regression equation, and we can see that it's got negative slope, so it should be negative correlation. And so this is approximately negative 0.945378, etc. Okay, So it's 945. So it's going to be negative 0.945. So straight away, again, without much thought, negative slope means negative correlation. You're straight away down to a choice between A and B. Even if you don't know how to find the correlation coefficient from what you have there, you should be able to look to narrow it down. So at least if you're guessing between, 2 or 3 options instead of guessing between 5 options, so increasing your chances. You don't need to solve the equation like I just did in the CAS. You can simply do the square root of 0.8, whatever it was, 0.893743. But you do just need to make sure that you then understand that if it's negative correlation, it will be the negative of that. Okay, question 11. A study was conducted to investigate the effect of drinking coffee on sleep. In this study, the amount of sleep in hours and the amount of coffee drunk in cups on a given day were recorded for a group of adults. The following summary statistics were generated. Okay, so we've got the mean and the standard deviation. Now, the thing to look at here is we want the effect of drinking coffee on sleep. Okay, so we want to look at drinking coffee as being the explanatory variable and the sleep to be the response, which means sleep is the y and coffee is the x. Okay, so therefore this is the mean of x, the mean of the coffee, and this is the standard deviation of x, and this is the mean of y, and this is the standard deviation of y, and this is r. Okay, so this is where we need to be able to refer to our formula sheet. I'm just going to open up the formula sheet to show you the relevant formula. Okay, here's the formula sheet, and here is where we want to be looking to these particular equations, which give us a connection between the least squares equation of the least squares regression line and the mean and standard deviation and the correlation coefficient of the two variables. So immediately, I haven't even read the question yet, but immediately seeing the information provided in the question, I'm thinking about these formulas. Okay, so here we want to know, on average, for each additional cup of coffee drunk, the amount of sleep decreased by da 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 da. Okay, so here we have to identify that this is talking about the slope of the least squares regression line. Okay, so if the least squares regression line is y equals a plus bx, this is talking about b. Okay, so on our formula sheet, to find b, we do correlation coefficient multiplied by the standard deviation of y over the standard deviation of x. Okay, so b is equal to the correlation coefficient times the standard deviation of y over the standard deviation of x. So in this case, that is negative 0.770 multiplied by the standard deviation of y is 1.12 divided by the standard deviation of x, which is 1.56. So if we work that out, negative 0.770 multiplied by 1.12 divided by 1.56. Okay, so that means that b is equal to negative 0.55. So that means, on average, for each additional cup of coffee drunk, the amount of sleep decreases, because it's negative, by 0.55 hours. So option A would be correct there. Okay, question 12. The table below shows the values of two variables x and y. The associated scatter plot is shown. The explanatory variable is x. The scatter plot is non-linear. Okay, so we're seeing that it's pretty clearly curved in that direction. A squared transformation is applied to the variable x. A squared transformation applied to the variable x can be used to linearize the scatter plot. The equation of the least squares line fitted to the linearized data is closest to. Okay, so I'm immediately ruling out A because it should have an x squared in it if it's the equation of the transformed data. Okay, if we're squaring the x variable, so immediately we can rule out option A. We need to be able to enter the data in, so I'm just going to pause the recording while I enter in the data, and then I'll come back. Okay, so I've entered in the raw data, so now I need to create my transformed variable, which I'm going to call x squared. Sorry, it's hard to type on this non-QWERTY keyboard. I should have typed that in first. Now, we can get it to automatically fill down the column by typing the formula in here. So this column is going to be equal to, now I've called my x data x variable. I strongly discourage you from calling your columns just x and y can create all sorts of problems when you're trying to solve other equations later on. I think even if you just call it xv for x variable and yv, at least use a two-letter word rather than just a single letter. Okay, so we want to do our x variable squared, so I can either type x var or I can go to my variables and select the one I want. So just press the variable button, the number above number 9, and I want to do that squared, and it will fill down with my squared x values. Okay, so now I want to do the regression. So it's going to be menu 414 for the linear regression in the form a plus bx, which is how it's always given in further maths. Our x list this time is not going to be the x variable, but it's going to be the x squared variable, and our y value is going to be our y variable. And we press enter and we get the regression over here, and so we can see it is y equals a plus bx, where a is negative 1.338, so negative 1.34, so automatically I'm seeing it's going to be b, and b is 0.546 rounded to 3 significant figures, so it will be option B, looking at what I can see there. Okay, so questions 13 and 14 based on the following information. So the time in minutes that Liv ran each day was recorded for 9 days. These times are shown in the table below. Okay, so we've got her day number and her running time, 9 consecutive days. Time series plot for the data is also shown. Both 3 median smoothing and 5 median smoothing are being considered for this data. Both of these methods result in the same smoothed value on day number what? Okay, so we essentially need to do both the 3 median and 5 median smoothing and work out which day do we get the same value. So 3 median smoothing, looking at the first 3 data points. Those 3, the median height, the median time, you've got 3 times there, that one will be the median one, so the median time is that time there, okay? So then we look at our next 3 data values, that value, and that value. Therefore looking for the smooth value for day 3, the median time is going to be this one up here. Again, you've got 3 times there, the median one is that one. Okay, so then we need the next 3, so that, and that. Okay, so we're looking at the 3 median smoothed value for day 4. So again, the median time, the middle time, is going to be that one. Okay, so then we look at the next 3, so those 3, median smoothed value for day 5. The median time is going to be up here. And then the next 3 is going to be looking at those 3 points. The median time is going to be this one. And then the next 3, the median time will be this one. And then the final 3 data points, the median time is going to be that one there, right on the data, right on the plot. Technically doing the median smoothing, you would join them with straight lines. Realistically, we're not completing the full smoothing, we just want to draw the plot, and so we probably don't really need to worry about that. Okay, let's think about the 5 median smoothing. So I'll change the pen color. So 5 median smoothing, we're going to want to look at 5 values. So 1, 2, 3, 4, 5. And we want to find the median time. So we've got 1, 2, 3, 4, 5 times. The middle of those times will be that one there. Okay. Alright, and so that's the median smoothed value for day 3. It's going to be here. Alright, which is not the same as day 5. So day 3 is not the correct answer. Alright, let's just keep working our way along. So 5 median smoothing, we need another point over there. Those next 5 points, we're looking at day 4. The median height here is going to be this one. Oops, sorry, forgot to change my pink pen. This one. Okay, again, you've got 1, 2, 3, 4, 5. So the middle one of those is that one. And so that's where we've got our point to where we've just marked it. Okay, 5 median smoothing. So now adding in this point. The median value, the middle value is going to be equal to, it's going to be equivalent to that one. Sorry, it's not a very straight line. It's going to be that value. Will be the middle time. So again, it's not day 5. Alright, let's forget that point and add in that point. So median times out of those 5 highlighted times, so we're looking at the middle height, is going to be this. So we're doing the smooth value for day 6, so it'll be equivalent to that. So still not the same as the 3 median smoothing. And so just our luck, it's going to be the last one, isn't it? Well, it better be, because none of the others are right. And so again, 5 median smoothing here, you've got 5 y values. The middle one is that one, okay, which means it is going to be the same. So this is the one we're after. That's where they're the same on day 7. So just unlucky that happens to be the last option. Question 14. A least squares line is to be fitted to the time series plot shown above. The equation of this least squares line with day number as the explanatory variable is closest to. Okay, so the first thing is with day number as the explanatory variable, we can rule out A and B. Okay, so day number has to be the x value. And then we want to do the least squares regression. So I'm going to insert a new page into my document, another lists and spreadsheets, and I'm going to be entering in this time series data. I'll just pause the video while I do that again. Okay, so I've entered in the data, so we're going to do menu 414 for the least squares regression. Our X list in this case is day number, so I just called that day, and our Y list in this case is time, which I just called time, and that's all we need. And so our least squares regression, we've got the information there. It is going to be y equals a plus bx, so that's 28.5 plus 1.76 recurring times x, and so that will be 28.5 times plus 1.77 times the day, so that's going to be option E. Okay, questions 15 and 16. Following time series plot shows monthly rainfall at a weather station in millimetres for each month in 2017. The median monthly rainfall for 2017 was closest to. Okay, so we want to know over the full 12 months, what is the median? Now, you could obviously enter all those data values into your CAS and get it to work out the median for you. But again, it's about working out, well, the median, if I've got 12 months, the median will be, 12 plus 1 divided by 2, so it'll be the 6.5th data value. So we want to find between the 6th and 7th monthly rainfall values. So this one will be the lowest one, so that would be the first if we were to list them out in order. That would be the second will be that one, the third will be that one, the fourth will be that one, the fifth is going to be this one, and the 6th is going to be this one. Okay, so it's going to be between this 6th and then the 7th, which will be that value there. Okay, so I would say, let me just get rid of some of these lines so I can read the scale properly, that the 6th value, I've gotten a bit unstraight there, let me see if I can use an actual line. It's a bit higher than it should be. But yeah, the 6th value is about there. So looking at the scale, each of those, so the 6th value is maybe about 96, 97, something like that. And the 7th value is pretty bang on 110. So if we look at sort of, 96 plus 110, divide it by 2. Let me go back to a calculator page over here. 96 plus 110, and divide that by 2. It's about 103 for the median monthly rainfall. Yep, which is an option, option D. Okay, question 16. If 7 mean smoothing is used to smooth this time series plot, the number of smoothed data points would be. Okay, so 7 mean smoothing, we would need 7 mean or median. Yep, 7 mean, doesn't matter, but 1, 2, 3, 4, 5, 6, 7. Okay, so that means that the middle of those 7 is this fourth one here, April. So April is the first month we would be able to do the 7 mean smoothing for, because if we used May or February or March, there wouldn't be 3 data values before that. Okay. Similarly, if we think about the other end, 1, 2, 3, 4, 5, 6, 7, the middle one of those is September. So we can do 7 mean smoothing for the September month, but we wouldn't be able to do it for October, November or December because there aren't 3 months that come after that. So therefore we can do 7 mean smoothing. When we do a 7 mean smoothing, the number of smooth data points would be the data points for April, May, June, July, August and September. So 1, 2, 3, 4, 5, 6. It would have 6 smooth data points. So option C. Alright, and then we're into the recursion and financial modelling. Okay, so consider the recurrence relation shown below. A0 is equal to 3, an plus 1 is 2 times an plus 4. So to get from each term to the next, we double and then add 4. The value of a3 in the sequence generated by this recurrence relation is given by. Okay, so a1 would be 2 times 3 plus 4, which is going to be 10. A2 would then be 2 times 10 plus 4, which would be 24. A3 therefore would be 2 times 24 plus 4, which is option D. Question 18. The value of a compound interest investment in dollars after n years, Vn, can be modelled by the recurrence relation shown below. So the initial value of the investment is $100,000, and to get from its n is in years, so 1 year to the next, we multiply by 1.01. So multiplying by 1.01, if we multiply something by 1.01, we're multiplying something by 101%, which means that is a 1% increase, and so that would be, and it's happening per annum, so that would be the annual interest rate would be 1%, so option C. Okay, question 19. Jeff purchased a computer for $4,500. He will depreciate the value of his computer by a flat rate of 10% of the purchase price per annum. A recurrence relation that Jeff can use to determine the value of the computer after n years, Vn, is Okay, so it's flat rate depreciation, okay, which means we simply subtract a fixed amount every year. So immediately I can ignore C, D and E where there's clearly some kind of percentage change happening from year to year, okay. The other thing is that it's depreciation, so it's going down, so it can't be option B either. So I don't actually even need to work out what the flat rate of depreciation is to answer the question. So this is where it's so important in the multiple choice questions that you take a moment to actually look at the multiple choice options first to think about whether you can eliminate some options. I mean, you know, it wouldn't be hard to work out the depreciation. It's 10% of 4,500, so that is 0.1 times 4,500, which is going to be, let's hope, oh sorry, I put an extra 0 on that, 4,500, which is $450. But actually we didn't even need to work that out. There's only one option that is showing flat rate depreciation. It doesn't matter what any of the numbers are. Okay, question 20. Consider the following amortization table for a reducing balance loan. The annual interest rate for this loan is 3.6%. Interest is calculated immediately before each payment. For this loan, the repayments being made are weekly, fortnightly. Okay, so what we actually want to think about is what was the percentage of interest in the first payment. So the initial balance is $300,000 and the first amount of interest was $900. So we want to work out what is 900 as a percentage of 300,000. Okay, so 900 out of 300,000, converting that to a percentage, 900 divided by 300,000 times 100 to get a percentage, so that is 0.3%. Okay, so it's 0.3% per payment, okay? 0.3% per payment. Okay, that's the interest. So if we know that the interest is 3.6% per annum, we want to work out how many 0.3s are there in 3.6. So we want to work out, well, 3.6 divided by 0.3, 3.6 divided by 0.3 is 12. okay? And so that means that this is 1/12 of the annual interest rate, and so therefore this is a monthly rate. Okay, so option C. Okay, question 21. The graph below shows the value in dollars of a compound interest investment after n compounding periods, Vn, for a period of 4 compounding periods. The coordinates of the point where n equals 2 are 2b, the value of b is. Okay, so let's have a look at what's happening here. It looks like it's not a linear rate, because we can see from in the first month it goes up by $80. No, sorry, it doesn't. I misread it. So it's 0.5. Oh no, sorry, I didn't misread it. I read that as 1,000. So it goes up by $80. Goes up from 500 to 580. So it goes up by $80. We don't know what the jump from there to there is, okay, and we don't know what the jump from there to there is, but we do know that the jump from there to there is, let me just work that out, 905.32 take away 780.45. So that's a jump of $124.87. So it's growing by a different amount each month. So it's not linear growth and decay, it's geometric growth and decay. Okay, we've got some sort of compound interest happening here. So therefore we actually need to work out what is the interest rate. We know that it's 4 compounding periods. So if in the first period we increase by $80, let's have a look at what that is as a percentage. So $80 out of the original $500 times 100%, 80 out of 500 times 100. Okay, so that is 16% per quarter, which is the compounding period. Oh, actually we don't know, it's just 4 compounding periods per period. Okay, so that means we are multiplying by 1.16, okay, every time we change. So let's just check that that works from this month to month, from month, or from compound period 3 to 4. So if we did 780.45, and we multiplied that by 1.16 to increase it by 16%, we indeed get $905.32. So therefore, to work out B, okay, B is going to be 580 multiplied by 1.16. 580 times 1.16, and so that is $672.80. So the value of B, $672.80, is option C. Question 22. A machine is purchased for $30,000. It produces 24,000 items each year. The value of the machine is depreciated using a unit cost method of depreciation. After 3 years, the value of the machine is $480. A rule for the value of the machine after n units are produced is... Okay, so the depreciation over 3 years is going to be $30,000, that was its initial value, minus $18,480. That's the value after 3 years. So 30,000 minus 18,480. Okay, so we lost $11,520 over 3 years. And so that means that the depreciation over 1 year is going to be 11,520 divided by 3. Okay, so that is $3,840. Okay, so we know in 1 year it produces 240 items. So it's $3,840 per 24,000 items. So if we divide both sides of this ratio by 24,000, we'll be able to work out how much it is for one item. So we want to divide by 24,000. So if we do 3,840 divided by 24,000, Control Enter to get that as a decimal, so that is 0.16 per one item. Okay, so it's 16 cents for every one item. So the value of the machine after n units are produced is Okay, so I'm the only one where I'm seeing this 16 cents is here, and this one looks correct to me. The initial value is $30,000, and we'll be subtracting 16 cents for every item. So 0.16 times n is the total depreciation if we've produced n items, and we're taking that off the 30,000. So it should be option E. All right, question 23. Joseph borrowed $50,000 to buy a new car. Interest on his loan is charged at a rate of 7.5% per annum, compounding monthly. Joseph will fully repay this loan with 60 monthly repayments over 5 years. Immediately after the 59th payment is made, Joseph still owes $995.40. The value of his final repayment to the nearest cent will be. Okay, so there's a couple of ways you can do this because they've given you quite a bit of information here. They've told you how much is still owing after the 59th repayment. Now, this won't be his final repayment, okay? Because that money is going to sit in the account for the last month and earn interest. So you could work this out by working out the monthly interest rate. So you could work out the monthly interest rate is going to be 7.5 divided by 12, 7.5 divided by 12, which is, sorry, I did times 12. Let's fix that. 7.5 divided by 12 is 0.625. Okay, so the monthly interest rate is 0.625% per month, which means this value is going to be increased by that. Okay, so the final payment, sorry for my scribbly handwriting today, is 995.49 multiplied by, we're going to increase by 0.625%, so we're multiplying by 1.00625. Okay, and that should give us the final payment after we've added on the interest from that last month. So 995.49 multiplied by 1.00625. So the final payment should be $1,001.71. So it should be option C. We could also do this using Finance Solver. So what I would do is I would first of all work out what the payments are. So if we have $50,000, so the first 59 payments, so if we do 59, n is 59, the interest rate is 7.5, the principal value is 50,000. We borrowed that, so yes, that's positive. The payments we don't know, so I'll leave that for a minute. The future value after 59 repayments, we're told, is 995.49, and payments per year are monthly, so there's 12 payments per year and compounds per year. Okay, so if we work out what the payment is, okay, so for those 59 payments, it's going to be $1,029.91. Okay, so now if we assume, I'm going to round that to the nearest cent, if we assume that we were to make that payment for 60 payments, sorry, I'm going to go up, for 60 payments, we want to know what's the future value. Okay, so, something's not right here. Let me have a quick look. Let me just pause for a moment. I've realised my error. Okay, so the future value, my apologies, won't be positive because we'll still owe that money. So sorry, the future value should be negative $995. Okay, so let's go back. So if we had, after 59 payments, the future value is going to be negative 995. Let's work out what the payment is. Okay, so the payment is $1,001.90. So it's pretty close to the final payment. So that would be the payments that you're making every time. Now, however, if we were to make that exact payment for 60 months, let's work out what the future value would be. So the future value would be 0.19, so 19 cents. It's positive though, so that means that we've overpaid by 19 cents. So actually, it should be the regular payment. So the other way we can do it is the final payment would be the regular payment of $1,001.90, take away the fact that if we were to pay $1,001.90 in the 60th month, we would have overpaid by 19 cents. So we're taking away the 19 cents, which is how we get also to $1,001.71. Okay. In this case, usually I would say Finance Solver is good for this, working out the final payment, but I actually think in this case, just adding on the interest to that last payment was probably the most efficient method. Okay, question 24, so the last of the core section. Millie invests $20,000 in an account at her bank, with interest compounding monthly. After 1 year, the balance of Millie's account was $20,732. The difference between the rate of interest per annum used by her bank and the effective annual rate of interest for Millie's investment is closest to. Okay, so we need to actually work out what the rate of interest was, and then we can work out what it is as an effective interest rate. Okay, so she invested in an account compounding monthly after 1 year. Alright, so let's edit our Finance Solver here. So 1 year, 12 compounding, monthly, 12 compounding periods. The interest rate's what we don't know. The principal value, she invested $20,000. She put that money in the bank, so that's negative 20,000. Sorry, negative 20,000. It doesn't refer to any payments. She's just investing that money and letting it earn compound interest, so the payment is going to be 0. And after 1 year, the value of the investment, the future value, is $20,732. Okay, so that's a positive amount because that's her money. Relative to her, she doesn't owe that money, that's her money. So that's a positive amount. So if we work out payments per year and compounds per year, it's monthly, so it should still be 12. Let's work out the interest rate. So it tells us that the interest rate, the annual interest rate, is 3.6% per annum. Now, in practice, she doesn't actually earn 3.6% per annum. She should be earning a bit more than that because every month the interest is being calculated on a slightly bigger amount. So that's what the effective interest rate is. In practice, how much interest did she actually earn over the course of 1 year? So what we want to know is, if you have a 3.6% interest rate with monthly compounding periods, what does that work out as an effective interest rate? So I'm going to get out of the Finance Solver and I'm going to go to Menu, 8 for Finance, 5 for Interest Conversion, and 2 for Effective Interest Rate. 3.6, comma, 12 compounding periods in the year would give us an effective interest rate. So this is the interest rate, this is the effective interest rate, would be 3.659998 okay, and so we want to know the difference between the effective interest rate and the annual interest rate. So the difference is going to be that 3.659998 etc. minus 3.6. So if we take away 3.6, it should be 0. Now all of these are to 2 decimal places, so let's round this to 2 decimal places. That would be 0.06% is the difference. Okay, so actual advertised interest rate 3.6% per annum, effective interest rate 3.66% per annum, and so therefore that's a 0.06% difference in the effective versus annual interest rate. Okay, so that's the core section of the paper. I'm just going to pause the video now and I'll resume and have a look at the matrices section as well. Right, so now we'll have a look at the matrices module. So there'll be 8 multiple choice questions here. These should take 18 minutes if you are doing it as a timed paper. Okay, so consider the following 4 matrix expressions. How many of these 4 matrix expressions are defined? Okay, so the first one here is addition, and when we add matrices they must be of the same order, which is the case here, so that will work. Here you're adding matrices where they're not of the same order, so that will not work. Again, adding matrices not of the same order, so that won't work. Adding 2 matrices that have the same order, and so that one will work. So 2 out of the 4 matrix expressions are defined. So option C. Question 2. There are 2 rides called the Big Dipper and the Terror Train at a carnival. The cost in dollars for a child to ride on each ride is shown in the table below. 6 children rode once only on the Big Dipper and once only on the Terror Train. The total cost of the rides in dollars for these 6 children can be determined by which of the following calculations? Okay, so often these problems can be solved by thinking about what does the answer need to be and then working back from there. So you know that the calculation that needs to happen is going to be 6 times 7 plus 6 times 8 to give, what's that going to be? 6 times 7 plus 6 times 8. So to give a total of $90. Okay, that should be the calculation that we get from the matrix multiplication. So that is 6 children spend $7 to ride the Big Dipper once, and 6 children spend $8 to ride the Terror Train once. Okay, so we want to think about which of these will actually give that calculation. And again, sometimes it comes down to just thinking about the order. So this is a 1 by 1 matrix times a 1 by 2 matrix. This would give a 1 by 2 matrix, so that's going to give 2 numbers. Now we just want to get one number. So that one's not going to be right. Doesn't matter what its answer is. This is a 1 by 1 times a 2 by 1, so this one's not even possible. Okay. This is a 1 by 2 times a 1 by 2, so again, not even possible. This is a 1 by 2 times a 2 by 1, which will give a 1 by 1 matrix, and it is possible. And this is a 2 by 1 times a 1 by 2, so it's possible, but it's going to give a 2 by 2 matrix, so that's not what we want either. Okay, so actually process of elimination in terms of finding a matrix multiplication that will just give one number, it has to be D. Okay, and again, you can have a look at the calculation here. Rows times columns would give us 6 times 7 plus 6 times 8, which would indeed be 90. You can get your CAS to check the calculation for you if you want, but option D will be the correct answer there. Okay, so question 3. Consider the matrix P, where P is the matrix you can see there. The element in row I and column J of matrix P is Pij, and the elements in matrix P are determined by the rule. Okay, so this really is just going to be a process of elimination, and so perhaps we just try each one for a couple of numbers until we find one that seems to work. So considering option A, if Pij is equal to 4 minus j, then P, for example, so let's think about P23, which should give us the number 3. That would be equal to 4 minus j, so where I is the number of the row number and j is the column number, so that would be 4 minus 3, which would be 1. Okay, but P23 should be 3, and so that's not going to be correct. Okay, let's have a think about the second option, so option B, so it's not A. Option B, Pij is equal to 2i plus 1, so 2 times the row number plus 1. Okay, so if we think about P23 in this instance, that would be 2 times 2 plus 1, which would be 5, which is not equal to 3, which is what P23 is. Okay, element in row 2, column 3. So also not option B. Option C says that Pij is going to be I plus j plus 1, so we add the row number with the column number and then add 1. So P23 would be 2 plus 3 plus 1, so that would be 6, so that's also not going to be correct. Okay, now, you don't have to think about P23, I've just picked a random element. I wanted to choose an element where the row number and the column number were different, just to be clear about what I'm doing, but you could be testing any other option. So option D, Pij is equal to I plus 2j, so it's the row number plus 2 times the column number. So P23 is the row number 2 plus 2 times the column number, and so that's going to be 8, which is not 3. And yet again, it seems to be the final option, which is going to be the correct option, we hope anyway. And then Pij is 2i minus j plus 2. Okay, so 2 times the row number minus the column number and plus 2. So that would be 2 times 2 minus 3 and plus 2, which would be 4 minus 3, which is 1, and plus 2, which is 3. So that one seems to work. Let's try it for another one. Let's try P11, which is also 1. Which is also 3. So it will be 2 times 1 minus 1 plus 2. So that is 2 take away 1, which is 1, plus 2, which is 3. Good. What about, let's try P12. So row 1, column 2 should equal 2. So that would be 2 times 1 minus 2 and plus 2. Okay, so that's 2 minus 2, which is 0, plus 2, which is 2. So that's going to be correct. What about P22, row 2, column 2? That should equal 4. So that's going to be 2 times 2 minus 2 and plus 2. 4 minus 2 is 2, plus 2 is 4, and so that seems to be correct. We could test the other two as well, but given the other 4 we know are incorrect, I'm happy to go with E as being correct on that basis. Question 4. Stella completed a multiple choice test that had 10 questions. Each question had 5 possible answers, A, B, C, D, and E. For question number 1, Stella chose the answer E. Stella chose each of the 9 remaining answers in order by the following transition matrix below. Okay, so this is actually like a permutation matrix because we're just going from one to the next each time. Each row and column only has a 1, 1 in it. So we know that she chose E at option 1. We want to know what she chose for question number 6. Okay, so question number 1 was E. Question 2, question 3, question 4, question 5, and question 6. Okay, so she goes from E to what? So if this question is E, her next question will be C. Okay, so she'll go from E to C for question 2. Then where does she go from C? So from C, she goes to A. Okay, so question 3 would be A. And then from A, she goes to D. So question 4 would be D. And then from D, she goes to B, and so question 5 would be B. And what do we want? Question 6. And then from B, she goes back to E. Okay. Now, actually, we could have worked that out because of, in particular, that we asked for question number 6. There are only 5 options. The fact that this is a permutation matrix where there's a 1 in every single row and every single column, only 1 in every single row and every single column, means that this permutation will cycle through the full cycle of 5 options before it then repeats itself. So regardless of the order here, this would have involved all of A, B, C, D, and E, and then immediately question 6 would be the same as question 1 again. So actually, we probably could have streamlined that process without having to think through the whole step, the whole process, the whole sequence. So option E for question 4. Okay, question 5. Which of the following systems of simultaneous equations best represents the matrix equation? Okay, so you could work back from the answers with each of these, but I think it's probably going to be, again, we don't want it to be option E, and we've tested them all and we could be here forever. I think it's probably going to be best to think about expanding out the multiplication here so that we can work out the simultaneous equations. So if we do this multiplication, it's a 4 by 4 matrix multiplied by a 4 by 1 matrix. So we're going to get a 4 by 1 matrix, okay? And the top number in the answer will become from doing the top row by the only column. So that will be 2 times V plus 2 times W plus 0 times X. Sorry, I'm just going to, it's a bit illegible. Try again. Plus 0 times X minus, so plus negative 2 times Y, so that's minus 2 times Y. Okay. Now then, the second row in the answer will be second row times left column. Now, the other thing is to recognise that this is equal to 2, 6, negative 8, 4. So the first equation is going to be 2v plus 2w minus 2y equals 2. Okay, and so perhaps we could rule out some options rather than let's rule them out as we go. So 2v plus 2w minus 2y equals 2. So that one's correct. 2v plus 2, that one's correct. That one's correct. That one's correct. And they're all correct. Okay, so actually I should have been a bit more strategic here. There was no point in working out the top row because they're the same in all of the answers. So let's have a look here at the second option. 2v minus 2x equals 6, 2v minus 2x equals 6, 2v minus 2w. Okay, only one of those is different. We can come back to that later. Let's try and find which equation has got the most variation. 2v minus 2y, 2w minus 2y, so they're different. 2w minus 2y, 2w minus 2y. Okay, so only one different again there. And what about the fourth option? 2v plus 2w minus 2x. Okay, they're all pretty similar. So what I would have looked for here is if there was, for example, one equation where we had, 2 or 3 different responses quite jumbled up, then we might have tested out that answer next. But given they're all only one of them are different, let's just work our way through and hope it's not option E again. Okay, so second row times only column is going to be 2 times V plus 0 times w minus 2 times x and plus 0 times y, and that has to equal 6. Okay, so it'll be 2v minus 2x. So 2v minus 2x, 2v minus 2x. So this one was wrong, okay? So not going to be E. Otherwise, it is correct at the second option for all of them. All right, third option. So sorry, third equation, third row times only column. 0 times 2, 0 times v, so 0v plus 2w plus 0x minus 2y. So that's going to be 2w minus 2y equals negative 8. So this one's not right. 2w minus 2y equals negative 8. 2w minus 2y equals negative 8. 2w minus 2y equals negative 8. Okay, so we're now down to 3 options. And so we want to have a think about the fourth equation. So bottom row times only column will give us 2 times v plus 2 times w minus 2 times x plus 0 times y, so shouldn't be any y, equals 4. So 2v plus 2w minus 2x. 2v plus 2w minus 2x, that one's correct. 2v plus 2w minus 2x, okay, that one's not correct. 2v plus 2w minus 2x equals 4, that one's also correct. What have I missed? What's different about those equations? Sorry, I missed the difference in the first equation. So we could have ruled one out with the question with the first equation. So we've got a plus 2y here and a minus 2y here. So it should be minus 2y in the first equation. So sorry, that one wasn't right. We should have ruled C out at the first instance. That one's not right there. So B ends up being the correct answer there. Okay, and then question 6. A water park is open from 9 AM until 5 PM. There are 3 activities, the pool, the slide and the water jets at the water park. Children have been found to change their activity at the water park each half hour as shown in the transition matrix below. Okay, so for example, 20% of the children will go from the slide to the pool each half hour. A group of children has come to the water park for the whole day. The percentage of these children who are expected to be at the slide at closing time is closest to. Okay, so let's have a think about 9 AM until 5 PM. 5 PM. That's 8 hours, which means it is 16 half-hour blocks. Okay, so we essentially want to think about the 16th transition. Okay, so we want to work out what t to the power of 16 is, which probably will be the steady state, but let's just check. Okay, so just going to enter in my matrix. So it's a 3 by 3 matrix, 0.8, 0.2, 0.4, 0.05, 0.6, 0.1, 0.15, 0.2, 0.5. And if we do that to the power of 16, then at the end of the park, the percentage of children who are expected to be at the slide at closing time. Okay, so we can see that there we have reached a steady state. You see each row is the same. The slide is the middle row, those who end up at the slide. And so we see that it's actually slightly different, but in terms of what's it closest to, it's 13.8-ish, so about 14%. So option A is going to be the correct answer there. So t to the power of 16 essentially gives us about 0.62, 0.62, 0.62. It gives us 0.14, 0.14, 0.14, and it gives us 0.24, 0.24, 0.24. So about 14% end up at the slide, about 62% end up at the pool, and about 24% end up at the water jets. So A for the slide. Alright, question 7. The communication matrix below shows the direct paths by which messages can be sent between 2 people in a group of 6 people, U to Z. A 1 in the matrix shows that the person named in that row can send a message directly to the person named in that column. Okay, so for example, this 1 here means that X can send a message to V. And there's an example here. So for example, the 1 in row 4, column 2, one was the one I happened to use, shows that X can send a message directly to B. In how many ways can Y get a message to W by sending it directly to one other person? Okay, so we want to know how can Y communicate with W in 2 steps. So we want to know the 2-step pathways, and so therefore we want to work out this matrix squared. Okay, so we want to square this matrix. So again, we're going to need, this time it's going to be a 6 by 6 matrix. Might just pause the video while I enter in all the numbers because it's a bit ugly. Okay, so I've got the matrix entered in. So now if I square it, I get all the 2-step pathways. I'm not going to write the whole thing out here. We'll have a look at it in the CAS. So we want to know Y to W. So Y to W is the element that's in row 5, column 3. So we want to have a look at that in our squared matrix. So row 5, column 3. Row 5, column 3 is going to be 0. So there are actually no ways that Y can get a message to W by sending it directly to one other person, so option A. Now, given that it was a 6 by 6 matrix, it was a bit tedious to enter that in and have to square it in order to find that. So you probably could have just worked through the individual elements in the original matrix instead. So if we want to know Y to W, let's think about who Y can communicate with. So Y can communicate directly with W, okay, so that's irrelevant, but they can also communicate directly with X and with Z, okay. So then having a look at X cannot communicate with W, and Z also cannot communicate with W. And so therefore, on that basis, there are going to be no 2-step paths. Y can communicate directly with W, but they cannot communicate via one other person. Okay, question 8, the final question in the Matrices module. An airline parks all of its planes at Sydney or Melbourne Airport overnight. The transition diagram below shows the change in the location of the planes from night to night. Sorry, I read that in the wrong. I read that with the wrong emphasis. An airline parks all of its planes at Sydney Airport or Melbourne Airport overnight. Okay, so the planes are either at one or the other. I initially read it as they all had to be at one. There are always M planes parked at Melbourne Airport, and there are always S planes parked at Sydney Airport. Of the planes parked at Melbourne Airport on Tuesday night, 12 had been parked at Sydney Airport on Monday night. How many planes does the airline have? Okay, so what we know is that the number that went from Sydney to Melbourne was 12 planes. Okay, so that means that 48% of Sydney's planes is equal to 12. Okay, so it means that 48% of Sydney's planes, equals 12. So that is 0.48. It tells us that S is the number of planes parked at Sydney. 4.8 times S equals 12. And so we can get our CAS to solve that equation. We can do the solving ourselves and know that S will be 12 divided by 4.8. And so that is, that's not right. What about, 12 divided by 0.48. 12 divided by 0.48, not 4.8, is 25. So that means there were 25 planes in Sydney. Okay, and then the other thing is we know that there are always M planes parked at Melbourne and always S planes parked at Sydney. There was another bit of information I'm coming back to. Ah, that's right. Because there are always the same number of planes parked at Melbourne, it means that if Sydney sends 12 planes away from itself, it must also get 12 planes back. Okay, so that if it sends 12 to Melbourne from one night to the next, then it must get 12 from Melbourne from that overnight as well, so that the number of planes parked at Sydney Airport is always S, so it's always 25. Okay, so we also know that 0.2, so 20% of Melbourne is 12 planes. Okay, so that is 0.2 times M equals 12. And so M is 12 divided by 0.2, 12 divided by 0.2, which is 60 planes. Okay, so that means there are 60 planes parked at Melbourne Airport and 25 parked at Sydney Airport, and each day 12 planes move from Melbourne to Sydney and 12 planes move from Sydney to Melbourne. So that makes sure that there is always 60 at Melbourne and always 25 at Sydney. So then the question is, how many planes does the airline have? So they park all of their planes in either Sydney or Melbourne, so therefore the total number of planes is going to be 60 plus 25, and so therefore they have 85 planes in total. So option E for question 8. And that is the end of the recording for exam 1 in 2019 from the VCAA. Obviously there are other modules. You might have done a different module. For the purposes of these videos, I'm only going to be recording the core and the matrices, which is the most commonly completed module.